So my name's Alun Owen, and I want to talk to you a little about statistics support. And the title I've chosen is Statistics Support, the Past, the Present and the Future. So what I hope to do is to tell you a little bit about how we got here today in terms of statistics support, what it looks like right now, and then I'm going to sort of delve into a sort of a crystal ball type thing and suggest what I think it might begin to look like in the future. So without further ado, got a few preliminaries. So this is my law of presenting. When I'm talking to students, I mean, I've been doing it for so long now that I actually quite enjoy it. When I'm presenting to people like yourselves, I start to get a little bit more anxious. But tonight I've got my partner with me, Angela. So if I don't do quite as good a job as I would hope to, then you can blame Angela for that. And just to say that she's one of my biggest supporters. She's also one of my greatest critics. We have lots of fun, but we also are very competitive. The jury's still out as to whether my PhD trumps her 2 degrees and MSc, but there you go. So I just thought I'd take a brief moment, first of all, just to sort of talk about John Blake, who the award is named after, because everything that I'm going to talk about tonight, in part, comes from some of the work that John Blake did, because back in the sort of 1990s, I've never met John in person, but I know quite a lot about what he did in terms of statistics support or math support. John was a big supporter of math support back in the 1990s, and he was one of the few people that really got the momentum behind it to get where maths and stats support is today. So thank you, John, and I'm really honoured to have received this award in your name. I also wanted to take a brief moment just to talk about some of the people that inspired me. My mum, obviously, she was my biggest supporter. I come from a working class background. I grew up in a mining community. Not many people went to university. In fact, I didn't go straight to university. I left school at 18 and realised the error of my ways and went to university at 19. But that's another story. My mum was one of the biggest supporters. She was happy for me to do whatever I wanted to do and whatever made me happy. I also want to mention Cyril, or Mr. England, he was known. I don't have a photograph of Cyril. I did attempt to get generative AI to give me a picture which I felt looked remotely like him. It completely failed. I gave up because he kept ending up with 3 fingers on his right hand, so I just gave up on that. I didn't want to do any disservice to Mr. England. I was fortunate in so much that I was in a comprehensive school in a mining type community, but I happened to be in a class of students who were very able mathematicians, and Mr. England was able to get us all to complete our O-level, yes, I'm that old, a year early. And that's unheard of in a comprehensive school of that nature. I don't have a picture of Cyril, but I thought the picture of the school canteen and the staff cars parked outside there might sort of conjure up the sense of the time. And then there's a lecturer, Mike Maher, who was at Sheffield University when I was an undergraduate there. He helped me to learn to love statistics in my second year. When I was in my first year, I didn't get it at all. I was a mathematician. I'd come to do mathematics, and I didn't get statistics. But Mike helped me understand what statistics was all about. I've not put the names of the 2 people at the end there because I just thought I'd give you a moment to see if you could recognise them, because they're actually a little bit older than that these days. But of course it's Tony Croft and Duncan Lawson. I've chosen those pictures and I don't have their permission for showing these 2 pictures. They're going to find out about it because I'm sure they'll watch the video. So sorry Tony, sorry Duncan. I hope you forgive me. But I think this is what they looked like around the time when they were doing all their sort of hard work to bring mathematics and statistics support around. And of course, I do want to sort of acknowledge a huge number of people that work in what's called the Sigma network, which I will mention, some of whom are here today. So thank you for coming and supporting me in this talk. Okay, so what is statistics support? I've mentioned it a few times already. Well, I'll talk about mathematics support first of all. This is a definition that was coined by Lawson, Croft and Halpin. And it's really a facility or a support for learning that's given to students, not necessarily of mathematics, but quite often they can be from mathematics, but not necessarily. Primarily, we're talking about engineers. So it was set up primarily to support engineers back in the 1980s, 1990s, when the mathematics problem became a thing, and mathematics support grew out of that. I choose the same definition, but I've just changed one of the words, necessarily to usually. Usually the students that come for statistics support are not from a mathematics background. And that opens up a whole new heap of challenges and makes statistics support a very different animal, I think, to mathematics support. If anybody wants to know anything more about maths and stats support, then a little plug for this paper written by some people that you might begin to recognise through my talk. That would be a good paper to look at. I do have a list of references at the end. Little history lesson. I just thought it was important to show how we've got here where we are today. It's been through a lot of hard work by some key people. And back in about 2000, just after the mathematics problem was sort of talked about and people got together, people like John Blake, to say what can we do about this to try and make this better. By the year 2000, about half of universities had some form of math support, but what we're talking about there is cottage industries. We're talking about one person doing a few hours a week, and that's it. They didn't have any help, they didn't have any specialist resources or any specialist equipment. But you can see how it's grown to more recent times. There hasn't been a survey of this sort since 2018, but we've got to a point now where nearly every university, if not all, has at least some form of mathematics and statistics support. I've put statistics support in bold there because this is what the focus of my talk is. And you might notice that it's around 2008. And it's at that point where Duncan Lawson and Tony Croft, who were the key people behind launching the Sigma Centre for Excellence in Teaching and Learning, which, by the way, I'm told is the only funded Centre for Excellence in Teaching and Learning that is still going today. It's not funded anymore. It's run purely on the hard work and commitment of all the people involved in what's now called the Sigma network. Okay, so what does it look like? Well, in some universities, they have a dedicated drop-in centre. Like I work at Coventry University, we're very lucky to have such a facility. So it's a dedicated space, it's in our library, and students drop in without having the need to make an appointment. And the point about it being drop-in is that the students can get help at the point of need. They don't have to wait a day or two or a week or whatever. They can come there and then. Some universities have a sort of a pop-up type service, or what's often been coined a maths cafe. So that picture there, for example, is it's quite an old picture now, but it's when the maths cafe was first being developed at Portsmouth University, and they were one of the first universities to develop that idea. And for some universities, that idea works better than needing a dedicated centre. Appointments is often a big feature. In person or online now is very popular. We have seen a decline in online interest by students. They seem to have gone back to face-to-face, although online has become a very important part of some institutions' delivery of this sort of service. If they've got students that are studying at a distance, or if they've got multiple campuses as part of their institution. And resources. Now that forms a very important part of support because students need learning resources. There's something called Stats Tutor, which I've been involved in, which is a free website. It's a bit creaky these days because it's been built many, many years ago. It's about 15 years old now, if not more. It's currently under redevelopment and it's going to be taken over by Newcastle University in the near future. So we're hoping that that will have a new look and will work much better. But this example here is what we've got on our own Coventry website, where we've got access to videos, worksheets, all sorts of other resources. Okay, so one important thing is that statistics support is not necessarily about the maths. I'm hoping that this video launches okay. We'll see how it goes. Here's one. test stats come through?
Yeah, I was hoping to get some help with carrying out a multiple regression analysis.
Oh, yeah, multiple regression analysis, okay. Right, well, to do multiple regression analysis, we're written like this: x transpose y is equal to x transpose x times beta. And if we rearrange that, we can get x transpose x inverse times x transpose y is equal to beta. And that's how you get your parameter estimates beta. Equations are great, aren't they? So that was a bit of fun that I had one day creating that with a colleague called Alun Marshall, who was then working at the University of Sheffield. But there was a serious side to that. What we were trying to develop are, or were, or is, still are, statistics resource, training resources to do statistics support aimed at staff. So, and one of the things I want to talk about today is the fact that a lot of people that deliver statistics support are not necessarily primarily statistically trained. They're often got a maths background, they've been employed to provide math support primarily, but of course they're getting lots of students coming in saying, can you help with SPSS or can you help with stats or whatever, and they'll do the best they can. And so what we've developed is some resources that might be able to help them with that. What stat support is about, sometimes it's about the maths. I didn't want to make the impression it's never about the maths, sometimes it is. What it is about, it's about the doing. So it's about designing questionnaires, collecting data, choosing a statistical method, using software to actually carry out the analysis, and then understanding what to do with the results that you get from that particular software package you're using. Do excuse the cheeky little pun there about the P's and the value. I put that there, I know, I'm sorry, I'm here all week. I put that there because we do have students literally coming into the centre and saying, my tutor says I need to get a P-value, can you help me? And for some, and for many, you know, that's not uncommon. And so that's sometimes what staff are faced with when they're having to give students statistics support. The point being that the students don't know what it is they want help with. And then that brings about a whole new set of skills that you need to be able to support that student. It's very different to math support because the student often comes with a problem. It's very clear what that problem is, and straight away you can get in and provide some support. I mean, the ideal isn't to do it for them, but to show them how they can work out how to do it for themselves. Occasionally we get the chance to help a student develop their conceptual understanding, so that is part of it, but it's not necessarily a common part. So why is stat support needed? Well, I've done a little analysis. Now this is very much back of the envelope stuff, so this wouldn't pass muster with any journal editors out there at the moment. I've not looked at, I asked my friends, Microsoft 365 Copilot, to look at the 60 benchmark statements on the QAA website and to look for an indication of whether it thought statistics, quantitative methods or data analysis were required within that subject benchmark, strongly recommended, suggested or not really needed. And I also did the same for research methods. Now, I'll show you the results for research methods first. Presumably you wouldn't see any surprise there. So research method, the point is that that features in pretty much every undergraduate degree there is. And research methods involves data analysis, probably. Here's the results for stats. So you can see that 16 out of 60, so a good quarter, actually require stats or data analysis or quantitative methods. So we're talking about accounting, economics, biosciences, maths of course, engineering. There are a quarter of all undergraduate degrees require some form of data analysis. And all those students need help. Another 7 are strongly recommended. So just under half is either strongly recommended or required. That's a lot, I think. So what I did with that was to think, well, how many students in the country are currently faced with having to deal with data analysis, quantitative methods, that sort of thing. So I looked at the HESA data. So this is 24-25. Approximately just under 3 million students at any one time are enrolled on our undergraduate courses. And my estimate is about half of those that require some help or potentially help with data analysis and quantitative methods. I'm going to show you some numbers just to back where I've got that up from, but I don't have the time to really talk about this in detail, but I'll give you a flavour of what I did. You won't be able to read this. That's not the point. The point is that there's a whole bunch of subjects here. I've put down here the percentage of those students or courses I think probably need some form of data analysis and quantitative methods. And I've come up with about 1 million students out of 1,300,000 on science. So about, 3/4 on science-based subjects. And I did the same for the non-science. No surprise, it's much smaller. It's about 1/3. And I've got about 1 million students on courses doing science-type courses that are faced with data analysis, quantitative methods. And I've got about 500,000 on non-science courses. And that's where I get my 1.5 million from. It's a lot of students. It's a lot more students than the number of students that are doing mathematics as part of their undergraduate course. And there lies a problem, I think. Added to that, we have demands by industry, by the economy, to turn out graduates that are very data illiterate. And there's a whole plethora of reports that I'm sure you've seen before. There's also access and participation agreements. We've got the TEF, Teaching Excellence Framework. So universities are talking about all the support that they're providing to students to be able to achieve the targets that they're setting out to achieve. And maths and stats support is now an important part of that. So it's certainly here to stay. And I think that statistics support in particular is going to be a very much bigger part of this as data and statistics becomes an ever increasing part of society. So who's doing it? Well, we did a survey last year. 36 people responded, about half are full-time. But the point is that, can you see the stats support column is quite small? So they're the people that are providing stats support as primarily their role. There are very few of those people. The vast majority of people that are doing stats support are either doing it as part of a role in math support, or they're a lecturer who's also doing stats support. And there are more staff that are employed as math support tutors doing stats than there are stats support tutors providing stats support, if that makes sense, if you see what I mean. I've got no sort of confidence intervals or anything on that, so clearly there's margins of error involved here, but you get the picture. There is good news. I mentioned the Sigma network earlier. So the Sigma network is a national network of colleagues in England and Wales primarily. Scotland and Ireland have their own networks, but we all work together. And the Sigma network exists to help each other as staff. So we're a very collegiate sort of organisation. And what we've been able to do with the Sigma network is run lots and lots of workshops, training courses. I've already mentioned the fact that I've been involved in developing some training resources for staff. And this picture here is from a workshop that we did where we delivered some of that stats tutor training. I've got some links here which show some of the links to some of these resources. So if anybody wants to have a look at some of these things, if you get access to the slides, then you've got the links to be able to look at those. This one last example here, this is called the Stats Tutor's Pocket Guide to Statistics Resources that I wrote with that same person, Ellen Marshall, some years ago, back in 2016 actually. That's called version 1. So far there isn't a version 2. That's now very outdated. We have had various discussions and meetings with interested people so far to create a version 2, you'll be pleased to know. So that's in the pipeline. So here's a crystal ball time. I've so far resisted any sort of attempts to have a picture generated by generative AI, but I thought I had to with this particular example. And I was actually quite impressed with what it did, because I don't know if you can make this out, but it's got this crystal ball here, and it says in there AI statistics tutor. And what it's referring to is an assistant statistics tutor. And that's where I see generative AI helping here. I see it very much as a good assistant to providing stat support. So here's some of my key things that I think are going to be important in the future. I think it goes without saying that there's an ever-increasing demand, as I've mentioned already, for data literate graduates. And somehow we need to do our best to make sure that we can somehow produce these graduates that meet the needs of the economy and for our needs. And that's going to take money because, well, you'll see in a moment, I'll sum up with the reason why I've used the money symbol there. Generative AI, I think, offers some help with that in two ways. One is with tools. So at Coventry, for example, I've got a colleague who's brilliant, Luis Sanchez Andalco, as well as being a good stats tutor, is also very technically minded. He, using Copilot Studio, has been able to develop a bespoke Copilot agent. So this is a sort of like a standalone, our own standalone Copilot with its own instructions, with its own knowledge base to help students with learning statistics. We hope to create a free, public accessible version of that in the near future. At the moment, it's not free to all because it costs every time it's used. So that's one of the ways I think that we can have generative AI helping as an assistant to providing stat support. And what we're doing with that, when we've got students coming into our drop-in centre, which right now is very busy because we're coming to that point of the year when all our final year undergraduates have got projects to hand in. So students having to wait if they come to the drop-in. Well, we've got student proctors who sit them down and say, can I show you Sigma Chat, as we've called it, which is our agent. And they'll take them through how to use Sigma Chat. And the feedback we're getting is very good, that in the most part, students are getting at least some of their queries answered. So that's the way that we're using it. So we do see it as a very, very useful assistant. It doesn't replace the staff because it can't. It doesn't have that ability to understand the nuances of the students' anxieties, additional learning needs, etc. But I also think that if we can upskill students to learn how to use generative AI for themselves, that's the important thing. Then they might get better at being able to help themselves using those particular types of things like generative AI. One thing we've noticed as a result of that is changes in help-seeking behaviours by students. So I've talked to colleagues at other universities, and it's not just us. We've seen a slight downturn in the number of students coming to us for statistics help, despite the fact that we still do the same amount of sort of advertising, marketing, and trying to raise awareness. There's been lots of changes in higher education at the moment. Lots of universities are facing staff changes, reorganisations, so that might be part of it, because we rely on staff to talk about the maths and stats support that's available. But we do wonder, and this is a hypothesis, I have no data to back this up, we do wonder if it's something to do with students using things like generative AI to get help, because it's kind of easier in a way. They don't have to admit that they don't know something, and they're there, they've got the computer, they can get help, they can get that help straight away. I do wonder though whether they're getting the help that they need. So it might be that at the moment there's a sort of a reduction in the quality of the support that these students are getting. So I think there's something there about upskilling students with, if they're going to use generative AI to help themselves, we need to help them learn how to do that better. Then the other thing, and I'm glad we've got some people from the Alliance for Data Science in the room, and that's because I think that data science is becoming a feature of statistics support. We get students coming in for stat support that are doing a data science MSc or a data science degree. So they're asking for help with things like machine learning, coding in Python. They're things that traditionally maths and stats tutors don't have expertise in, particularly maths staff. They've never had to deal with managing large databases, SQLs, non-SQLs, and all the different software that goes with it. So there's a sort of a skills gap, I think, that's beginning to appear with the skills that people working in maths and stats support have if they're to meet the the demands of maths and stats support in the future, or stats support in particular. So what I think is going to need to happen is to have some sort of training, CPD, available to staff to be able to learn how to code in Python, because these kids are going to learn how to do it in school, and we're going to have to make sure that we're not left behind by them. We need to know about things like random forests and other machine learning models. And who's going to train the staff to do that? Well, the Sigma network does what it can, but it's not big enough to be able to do that. So I just wonder whether there's something that the Academy for Mathematical Sciences might be able to help with here today. And that's where I'm going to stop. Thank you very much.
I'm very glad to be here to celebrate with you. I thought very hard how to structure this talk, because it's a different talk to the ones I'm giving usually. So I hope you like it. So I decided to start with, first of all, it was a title. And I think for me, mathematics is about creating bridges between academia, the outside world, and across science, and across policy, and with companies. So I would like to go through a tour of my life, I guess, that would show how this all comes together. So I am Cypriot. The strong accent might tell you that already. I grew up in a household with 3 other siblings, and I went to a state school. That's my grandpa there, and thank you, my uncle and aunt, for coming with me today, because my parents, my mom couldn't come. So that's me there. I don't know who I'm waving to, but look very happy because there's barbecue in the background. And then I was very fortunate to get a scholarship to go to Cambridge when I was 18, and then I studied for a bachelor's in mathematics, and this is when this huge jump between the school, where math is easy and you can do everything, and then suddenly you go to university that you have to study really hard, and still there are things you don't understand. And this is when I started thinking about math in a different way, that how do I explain things to myself, how do I find other ways to understand things. So after my bachelor's, I really did feel the pull at that time, the last year in Cambridge, that I wanted to do something more applied. So I applied to engineering school. So I went to Columbia for a year and did a master's in applied physics and applied maths. And this is where math started becoming more applied and more tangible for me. I did want to come back to the UK. I moved on to Oxford, and this is where I felt that things clicked, because I had these years where I wasn't sure, should I have become a mathematician or not? I mean, just in all honesty, this is what was happening. And there I discovered teamwork, modeling teamwork, and worked on an industrial project, and suddenly it was all about working with people and working on real life challenges. So for me, it was like, wow, this is it. So it took a few years, obviously. It was like 4th year into my study or 5th year into my study. And of course, the other thing that I try to also do still until this day is to have fun with people. So it was amazing how these teams that were created through the course, the MSc, the same people who go out to BOPs, which are the Oxford calls their parties in colleges, and have great fun. And that brought us closer together, and then we worked together more. So it was a very nice environment that still continues doing that, because I had the chance to become an external examiner. They are keeping the ethos. So I'm sounding promotional for Oxford, but this degree, I think, did change the way I saw mathematics. So what did you hear? Somebody? Nobody? Yeah, who said sonic boom? Yeah, it's a sonic boom. So I stayed on to do a PhD on sonic booms. This is a military aircraft, the one that just flew and broke the sound barrier. It was a European program called the Sonic Boom European Research Program. It was interdisciplinary, co-funded by industry, Airbus and Dassault Aviation. So we had lots of visits to France to talk with industrialists there. And I was the only woman and the youngest, which can be tough if you're a woman in the room, but not so much actually. People were very nice. I didn't have bad experiences, but sometimes you start thinking, what is my role here, etc., the usual imposter syndrome, etc. But anyway, things moved on. I did the PhD, and this is where I also discovered my love for science communication. It was the first ever doctoral talk competition then in 2004, so I decided to enter and got the prize. I said, oh, maybe I can do this. Maybe I can talk about maths in a way that other people understand that are not mathematicians. So I was very intrigued by that, and I enjoyed it very much. So a few years later, I sent a pitch to TED-Ed. So everyone here can do it. It's 800 words, and you pitch your idea with 800 words, and then if they choose it, they choose an animator to work with you to create a video on a research topic of interest. So this came out a few years ago, about more than 10 years ago, and it has quite a few views because people love sonic booms, it turns out. And it also can be used as an educational resource. That's the whole thing with TED-Ed. At some point, because it was a quite intensive experience, I will do another one, but I'm not looking forward to it at this point. So one thing that was driving me along with applying maths to real life challenges was this idea that maths can be used to create common good, to do good to the world. And it still drives me to this day. And in fact, when I was searching for PhD projects, I did talk to Philip Maney for doing a PhD with him, and then this other funded project came along. I was an overseas student. I absolutely enjoyed sonic booms, but when the PhD finished, I thought, okay, let me explore biology now, because I felt this very much closer to the humans. So I did a short postdoc with Philip Maney and John Chapman in Oxford back then, and this was my first collaboration with experimentalists. Then I moved on to Nottingham and worked on cancer modeling. There were experimentalists in Sheffield, and we were looking at modeling magnetic nanoparticles that are injected in the body. They reach the tumor. That's the idea of magnetic hypothermia, and then you switch on a magnetic field, which then can create enough temperature in the tumor to burn the tumor. Hopefully, that's the idea of magnetic hypothermia, and this was a project by BSRC back then. So that was very interesting, and it was a very good introduction to data-driven modeling and the ultimate idea that you can actually help clinicians do things better, which again, I still find to this day very fascinating that as mathematicians, we can have this impact. So after that, I was looking for something, I don't know what it was, and I said, I'm gonna go outside academia and try my life there. And I went out for a few years, and I did technology transfer and I got some skills I do use to this date. So I was very happy for that move, actually. I did management consulting. This is very intensive environment where every 2 months you switch a project and you do various different problems. For example, we worked on energy and retail, and then there was this client that wanted to expand in the Middle East. So with a new drug that is similar to Nexium, for example, can they do that? Can they not? So it was a lot of data analytics and a lot of presentations. So I got quite a few skills there, I think. Again, teamwork, that I started feeling that this is exactly the way I want to keep working. Ideas to practice, project management, because actually I did tell you about this too, but then at some point I wanted to discover the artist within me, I went to New York and did a couple of months of filmmaking, which was not science related, but somehow again this came to help later on with projects that I have been doing afterwards. So it was a very good experience, a very interesting one. Again, people worked together very closely. It was a very productive atmosphere. And I then entered production company where I wanted to apply my filmmaking skills, but I ended up doing business development, which was very interesting actually. So there was this exhibition Tracing Istanbul where 100 artists from Greece, they were presenting their works at Istanbul, at 2 locations. So that was very interesting. We had to pitch these documentaries that were related to this exhibition to various people, etc. A very interesting experience. So, and then I thought it's about time to go back home. So already 15 years had passed from there. So I went back home, and it was a time back then, 2010, where the science communication was starting to move in Cyprus. So Fame Lab came on 2011 and I participated and I met some amazing people. They're all very excited about communicating science and maths to the outside world. I had the opportunity to give also a talk on rethinking mathematics to mostly a non-mathematical audience. You can find the link if you want on YouTube. And I was also teaching full-time non-mathematicians for the first time. And that again, this was a push to think, how do I communicate? How do I communicate in maths to people that if you ask them what is 3 minus 10, sometimes they struggle to answer, right? So you have to get new ways of explaining things. And it was an interesting challenge, actually. I did enjoy teaching. I still enjoy teaching very much to this day. And then this momentum on science communication was building up. Many other people started joining every year Fame Lab. And eventually, 4 years later, we co-founded with 3 other people a non-profit. And we said we need to do this science festival in Cyprus. So this is what we did. We called it the Mediterranean Science Festival. And again, community building, teamwork, entrepreneurship with this non-profit organization and interdisciplinarity. So I will play a video now. I hope it does play. hope you like the video. Every time I see that, a bit of tears are coming to my eyes because it was such an intense period, but so rewarding that we got all these people together to do this thing and to get the children to enjoy so much. It was, yeah, still to this day that I feel touched by it. And then we did it again 2 years later, and then as things that are happening with volunteering, it's not going on anymore. But hopefully somebody else will revive in the future. So the other thing that I want to talk about is European studying groups with industry. Around the same time, 2015, the Mathematics for Industry Network came about. It was funded by the EU, and the main aim was to create new studying groups with industry across Europe and affiliated countries. So I joined that network, and I initiated in Cyprus European studying groups with industry, ESKI, and 2 of them happened. So this meant that we had to go around in the country and talk to various types of companies and governmental organizations and non-profits to get challenges. If people don't know, these are week-long intensive workshops with industry. Industry in the wider sense, as I said, is different types of external partners. So for example, we looked at improving bus routes in Nicosia, increasing the creativity of toys. And Gino was a small company that they have these Lego-like toys. You can see an example there. So they were asking with 30 units, 30 pieces, can I create more toys? That's what it means, increasing creativity in this case. Managing an aquifer, the Water Development Department of Cyprus had this problematic situation with an aquifer that water from the sea was coming in and many people were throwing stuff inside. So we worked on that as well. And for other ones, delivering ice efficiently to many parts in the island. Optimizing filter performance. This was a company from abroad, actually, a startup. Reducing fuel use in tugboats. So that was with a large company. And one project that, again, close to my heart, breaking barriers for women in science with a non-profit. So what is the idea of the studying groups? They are catalysts. So the idea is that you come together for a week, the company presents on the same day, then intensive teamwork happens, and it's very interesting how you, as an organizer, you have to play with the team dynamics. And Heather is nodding because you've been doing that for a long time. How you put the right people in the room so that you have enough senior people, enough junior people, enough people that know stats, enough people that know other types of skills. Owen was there as well in the tugboats problem, so Owen is nodding as well. So it's this idea where you get this very intensive teamwork environment again, and by the end of the week, you are supposed to have some results to show to the company. And the company from there, ideally, if you've done it well, and I haven't seen at this point any kind of such situation go wrong. Actually, it's always the companies get impressed how much in 4 days and a half you can get so many ideas out, so many directions forward. And this is what leads to follow-on projects that happen. So one such project, as an example, was with the Water Development Department in Cyprus. So they gave some more money, and then MINet also gave some money, and we got people to come over to Cyprus and work together for 2 months or 3 months, if I remember well. Sorry. And then we got to present this to the senior managers at the Water Development Department. They had there, one of these people is a water engineer that was going to take our algorithm and implement into their management system. And this also led to a journal paper because we did have a lot of problem and a lot of challenge to convince local mathematicians to join studying groups. So we did have 65 researchers from 25 countries across the 2 workshops, but like, I don't know, 10 of them were Cypriots. And this is because people, I guess in the UK, this is mature and people do understand a lot about impact and how maths can be useful and useful for society and economy. And we have a whole system of assessing that. Such incentives don't exist in Cyprus and in many other countries. So it was very difficult for a local mathematician to be convinced that this studying group has value. Yet we didn't get sufficient number of people, I would say. This went on, and then there was some activities going on afterwards, after the 2 workshops that we ran there. But it is a question that we should ask ourselves: how do we start a new ecosystem? What are the incentives we give to people to actually engage with this idea that math is useful and it can create lots of good to the world? I'm still haven't found completely the answer, but I do know that it was very appreciated by some people in Cyprus that the studying groups happen there, and we're now discussing whether we can actually revive that again. But of course, you need some local support for that to make it happen. I have another video. So that's, remember I told you that my filmmaking days came, they were useful because both the video I showed earlier and this one, I work closely with the production company to, decide what words to put there, what are the cuts, etc. So I ended up using filmmaking in this context. I will play just 2 minutes of that because that's a 5-minute video, but let me see.
This is the second study group with industry in Cyprus, after the first one that happened in Limassol in 2016.
So we were very lucky to have 37 people from 10 countries, and it was very nice to see a mix of seasoned participants in study groups that have been doing this for many years, and also newcomers who had the chance to work on a problem.
This study group in particular has been funded also by the MyNet network, which is a cost project funded by the EU, and so it's a big opportunity that the EU is giving to mathematicians to meet industry and industrial problems.
We are also trying to create a very simplistic model of how the gap between females and males' salaries can increase or decrease based on different factors. So the experience of the study group here in Cyprus has been amazing so far. We divided ourselves in Team A and Team B. People who were more interested in a specific area, they were free to choose which team they want to go, so they went to Team A or to Team B. Somebody plugs the machine on the projector and says, this is a task, who wants to grab A, B, C, and everyone's really keen to help so we can move forward tomorrow.
When you're doing research, it's not often that you have an opportunity to interact so closely with such a big group of people and with such a range of experience. The results from industrial maths can have a lot of impact.
For example, instead of doing physical experiments that could be hard to design and hard to carry out, you can do these things on a computer, and then you can do lots and lots of simulations that would be very difficult to do.
Something that many industries haven't tried.
Okay, abrupt end. So this was a video that we got funding actually, and it's a video that is used by ECMI to show how a study group is done. So it was used in that way, and it exists on the ECMI website. So this part of the talk would be not complete. It would not be complete if I didn't thank all these entities and people that came together to support this initiative. So, for example, KPMG supported the workshop twice. You already heard about MINET. hosted by the University of Cyprus and many other supporters. But of course, personally for me, I felt so touched by the support and mentorship by specific people. For example, Jo Jordan, that many people in this room know, and she couldn't make it tonight, was the chair then of MINET, and very personally really gave a lot of support to the initiative. The ECMI, European Consortium for Mathematics in Industry, Paul Hjort, Alessandra Micheletti, and Vivi Rothschaffer. Some people know these people here. In Oxford University, very strong support by Ian Griffiths, Hilary Ockendon, Imperial, you saw Dimitrios there, and Smith Institute, last but not least, and David Orright, who was one of my PhD supervisors, was sitting down with me online, checking these challenges that we found. Is it good? Is it not good? How can we translate to a way that it can be uptaken by the team when it comes to the team? That's the other translation element that should happen. You should massage this challenge before you give it to the team. So it was all these resources coming together to create these 2 workshops in Cyprus that led to many projects afterwards. So that's a nice photo. Everyone is exhausted there. I don't but it's the end of the second workshop. And just one comment on one of the co-founders of this of the studying groups was the EU project SciShops, which was part of the Horizon Europe, Horizon 2020, sorry, Science for Society pillar. And it was the idea that you create research together with the communities. So it has an official name called Community-Based Participatory Research. It was many millions, actually, 3 million, and the whole idea to get 250 societal challenges identified across Europe. So we also did that in Cyprus, and we embedded part of that into the studying group. It was an idea I had so that we could get more money, but it was also a good synergy because, for example, we created a workshop before the studying group called Breaking Barriers for Women in Science that we used as a part of the identification process. Instead of me sitting together with the CEO of the president of that nonprofit, and she tells me what challenges there are, we got here together with many stakeholders, and we got to write down in a structured way what are the challenges. And then some of those challenges we fed into the studying group. So I found this to be a very good model of generating challenges for studying groups, actually. And this solidified my love for math that generates societal impact. I also would like to talk a bit about, I haven't put any equations, I think just one slide, but would like to get you back to mathematical biology and working with experimentalists and clinicians. So one big pillar of my research for the last few years has been embryogenesis. It started from far back from that Oxford postdoc I mentioned and the experiments in Caltech. So I'll play this video. Why is it not playing? I can do it from here. So I would like somebody to tell me what they see here. So you see the stained, bright stained stuff, right? This is part of a frog. And the bright stains are indicate cells. And you see here that big flash. That big flash is a calcium wave, as we say. So 96% of our calcium is in the bones. We know that. The 4% that is not in the bones, it's distributed across our body in all our cells and is responsible for a very wide range of processes in the body. One such process has to do with embryogenesis. And there are large calcium waves and small calcium waves there, and they are coupled with contractions. When I played the video, you could also see things, the tissue moving. So this indicates to a mathematician, to a modeler, that it's some sort of mechanochemical coupling, as we say. The forces in the tissue come together with the biochemistry in the tissue. And that was experiments from 2001. When I was getting back to research around 2015, after all this outside of academia period, I was looking for other experimentalists to collaborate, and I found this lab in Cyprus. It was recommended to me by somebody in the States. This is like the universal, across the world collaborations, and I got from Lance Davidson in Pittsburgh, go and look at the Skouridis lab, and I said, this sounds Cypriot. So I checked out the lab, and it was just 1 hour from where I was. I said, this is the universe talking to me, I should go there. I emailed Paris Skouridis, who was the head of the lab. He said, oh, that's great, because Paris had worked in the States, actually, and he had worked with modelers and physicists, even though he's in biology. He was very open to a chat. So I went over, we had a chat, and this led to ongoing collaboration for 10 years. It's a very big lab where they also do, except of embryogenesis, they do cancer modeling, cancer experiments as well. And these particular experiments, I'm going to play them, I think, from here. It doesn't go through the laser pointer for some reason. So again, it's a frog tissue. What do you see here? Kind of looks similar, right? There's a big difference, though. It's a similar process. Again, you get these flashes, and these are, again, calcium signals. Is when calcium gets elevated, and then it's the choreography. It's like a calcium flash there, and then here and there. So you have this choreography, and if the choreography gets disturbed, then you get embryo malformations. And this is exactly what also the 2001 experiments had found in a different embryogenetic process. So we linked all this together and created a paper along with Philip Maney and John Chapman, that with the modeling and this data from these experiments. So basically, I started working on this again. So we had this continuum models that led to a series of papers on looking at this as a continuum. But then later on, we had a PhD student with Tim Phillips, who is sitting in the room, Abhishek Chakraborty, who also looked and developed a very comprehensive cell-based model of the same process. So I will play these videos. So you can see there, hopefully, that the choreography of calcium flashes I mentioned earlier. And here, you see the same thing again. There is a it's like a continuum. There's like the tissue as a whole, and there you have the individual cells and how they interact with each other. So it's very different. And this model actually led to a quantitative reproduction, of experiments, and to open source software. So this is still work that we keep extending, and as I said, the software could also be adapted to wound healing and cancer, for example. And the same effect, not weirdly, it's actually, if you understand calcium, you expect that something similar will happen when eggs are being fertilized. You will get the sperm coming into the egg. It's injected actually in the lab. And when you, would it play? Another video. And you see here, when the sperm is fertilized, you get these calcium spikes. You can see them in the first, that first there is a spike, another spike, another spike. The moment you get that spike, you get some swishing motion in the egg. So again, this is how the movement and the mechanics are affected by the calcium. And it seems to me that there is a two-way feedback. But one thing that we don't understand is why this feedback seems to be destroyed there. So if we understand this, we are on the way to create a day one non-invasive method for choosing the best embryo. Now, clinicians have to wait 5 days to choose the best embryo. So this means we have a huge potential for saving IVF clinic time and money. And of course, it's much better for patients. It's nerve-wracking for the patients to wait 5 days to know whether their embryos have formed or not. Embryos have formed or not. How this goes, you have non-invasive high-speed cameras and you can track these motions and from there infer how calcium behaves because of this coupling between the two. You cannot track calcium because basically you destroy the egg if you do that. So that's why you need the mechanics, and this is a way forward if we achieve. We work with so many students by now. We have a good model for the calcium, and we still have to couple with mechanics. But I thought to mention this because this is, again, one example where math can make a lot of difference. It's a patent that the experimentalist put in, actually, about that non-invasive methods, which was then didn't progress before we entered the picture because of the lack of mathematical modeling specifically. So we need to understand how this works. Just to summarize and to say why are we working on IVF? Well, you have success rate stuck at 30%. We keep hearing about IVF and we think it's a hugely successful process. Perhaps it's not. And it has been stuck for 30% for many years. So we need all the help we can get from all disciplines to make that success rate increase. The demand for IVF is increasing rapidly. And the more we can do to help people struggling with fertility to have a baby, the better would be. So we work with the London Women's Clinic, and they co-founded a PhD student as well. And the team Ostler worked on various things, choosing the best embryo, looking at the temperature modeling in embryos, and then some more sophisticated math on imaging algorithms in fertilizing eggs. And eventually, the next year, we applied to GW4 with Thomas Woolley, and we got the INFER network started. So this is about bringing exactly together mathematicians, physicists, computer scientists, clinicians to come together and see how they can improve IVF success rates. So back to science communication, we are thinking with Thomas, how can we depict what happened in these workshops we are doing, co-creation workshops again, in a nice way. So we got a cartoonist in the room, and she created, that's one of the things she created. So just showing this as an idea if somebody wants to do the same, because we really enjoyed working with her. So many thanks to all my collaborators. I already mentioned some of them. And now I would like to talk a bit about working with policymakers and other disciplines. So during the pandemic, I've also seen Julia's great talk on when she got the same prize 2 years ago, and she talked a lot about how all the modelers, many modelers, went on and very intensively worked on guiding, informing policies on the pandemic. So in Wales, there was a lot of movement obviously going on as well in collaboration with SAGE. So at that time, very quickly, together with Ian Griffiths, we submitted a grant, and we got it. And then this basically catapulted us into the technical advisory group of the government, where people very quickly were discussing things like, should we open the gyms, and do we need plastic screens in taxis? What should we do with air purifiers? What should we do with masks? So all these questions coming all the time. And so it's a very intensive period, very rewarding as well, because you felt you were at the forefront of doing something very useful. So we created an infection risk model that was published in 2022, eventually. And just to say that we focus, and we still focus, on airborne transmission. What is airborne transmission? It's viruses that get carried through air. And you see there a woman sneezing. There is a cloud coming out of that, of her mouth, a cloud of droplets. The large droplets will fall to the ground. This is precisely what informed the 2 meter social distancing rule during the pandemic. But these sneaky aerosols, they evaporate very quickly, and very much like the smoke of, you smell the smoke at the other side of the room, the same way you can get infected by aerosols. So it's very important to understand this route of transmission, as we say, which also is shared by other diseases around us. And it's important to know that aerosols remain in the air for quite a few hours sometimes. So eventually, building on work during the pandemic, we created the virtual infection risk indoor simulator. So this combines airborne transmission, people movement, and architecture and design for the first time. Why architecture and design? Because when we were going to the meetings with the policymakers, they were very rightly say, okay, you predicted the infection risk in a square room, but my room has furniture. I have many rooms. Why? Why are you not doing that? And said, we don't have the capability. That's the only thing we can predict at the moment. So I found Wasim Jabi in architecture in Cardiff, who coincidentally had developed over many years a software where you can use any building and depict it as a graph on the computer. So this was a very nice collaboration that started 3 years ago now. And just to say a bit about the math without showing actual equations, we have for the airborne transmission a virus spread model. People movement is an agent-based model. You have these agents moving around with certain attributes on each for each one. Do they wear a mask or not? How fast are they walking? Are they super spreaders or not? So you can customize each one of these agents. And the architecture and design, as I said, Professor Wasim Jabi had created Topologic Pi, a very nice software that you can depict any building on the computer. So the outputs are virus concentration and infection risk, which is how likely it is to get infected. And this led to a series of papers on this that you can look at. Are the slides available afterwards? I guess if people can, yeah, you can email me if they are not available. So just to say that during the pandemic, many people use the Wells-Riley model, which is just on the ordinary and differential equations. So basically, they are saying that infection risk only changes with time. But this is not true. As we said again for the aerosols, if you are standing next to the person that is infectious, you are much more likely to get the virus than when you are far away. So it's obvious that where you are in the room plays a role. So this is what we extended to a spatial representation of the infection risk. And just to show you now some examples, we chose an imaginary care home with 6 rooms and 2 common rooms. And you have 6 people. They start in their days residing in those rooms, and then during the day they interact with each other. And you can see that by the end of the day, 3 of them will get infected if 1 of them is infected. So, of course, this idea is scalable. Any building you can get, and you can model with Topologic Pi. You can put agents in and then precisely quantify how long, you also get how long it takes for them to get infected. And we can compare many interventions like this. For example, should we wear a mask or not? Should we reduce time in the common room? We based this on the qualitative descriptions of interventions in that report by the UK government, and translated this to quantify them, basically, to compare the infection risk for them. Small supermarket, as well. This is a prototype, a paradigm of a case where you have people coming in and out, 240 people within 3 hours, and they stay on average 5 minutes in the place. We confirmed that improving ventilation reduces infection risk. The thing is, by how much? And again, this is how mathematics is useful, right? You can quantify how much the ventilation reduces the infection risk. And we can identify hotspots, as you can see there. We also looked at behavioral interventions. For example, should I wait to go to the supermarket? And we found that even if you wait after 10 a.m., nothing changes in the risk that you experience. And we did a lot of effort to use diverse data sources to calibrate the model. Neha is sitting at the back of the room. She has worked on this slide. Thank you, Neha. And that culminated with 2 impact acceleration account grants to an app that connects the idea of science communication for, however, policymakers, architects, space managers, and the public together. And the same skills that you need to communicate to the public, turns out, I realized during the pandemic, is what you need to also talk with policymakers and other non-mathematical audiences. Do I have time to show this very, very quickly? I think in the interest of time, it's a very memorable virus.app. You can go and look at, choose the examples. We have the care home and the supermarket, and you can see people, is what I showed you in the GIF earlier. So it's about pulling things together, and we also got to be finalists to the GW for Open Research Awards last year for this. Thank you to the various team and our collaborators. We still actively work with Public Health Wales and the Welsh Government to find more settings where we can apply this app and get infection risk. And this is, of course, to create healthy, energy efficient buildings, because what is the new, what is a good building to design, right? And how do we retrofit old buildings? So these questions came to the forefront after the pandemic, and this is what we are looking at. And for example, with another PhD student, Emma Shelley, and Thomas Woolley and Wasim Javi, we are looking at how do we combine energy performance and infection risk, because it hasn't been done up to now, unfortunately. And then we can use machine learning because we have a very big data set of residential buildings we are looking at. So just to finish very quickly on other structures and that I initiated in Cardiff. The Maths Adventure Day happened once, and it was a mini maths festival, basically, where you had our staff and students coming together and delivering interactive activities to about 250 participants. We have a Maths for Industry Day that is an annual event. Third time it happened last January. 40 external partners joined. It's maths, and also we invite people from other disciplines there. And an industrial advisory board that has 20 plus people from business, industry, and government, and this advice across the whole spectrum of our activities. And thank you, Jonathan Thompson is our head of school, is here today. So the department really supported these activities, and they have been going well. And just to finish, I think that's my last slide. Over the years, talking with people, enjoying teamwork led to more and more interaction across the UK and Europe. So the yellow is stuff that already finished, and the green is stuff already active where I'm involved. So for example, EU Math In is a network of networks that Newton Gateway is representing the UK. So I went there coincidentally in Cyprus. It was the annual council meeting. And I will finish my talk with the Gurion Amphitheater in Cyprus, a place that is still bringing people together over thousands of years. And this is very much how I think about mathematics, connecting everything. So thank you very much.